Good evening, y'all. Hope you're having a great night. Today I want to teach you how to describe and represent relations or relationships between two variables. Please make this the title on the next free page in your math notebook. And then after that, clear those distractions, turn everything off, empty your hands, clear your mind, and off we'll go. All right, some things to remind you of and that we've talked about in the past that are important. Coordinate plane is where we have been making graphs for the last several days. We've been keeping pretty much everything here in positive territory in quadrant number 1, like that. And also ordered pairs are what we put on there. So we think of things, if I kind of make a graph here, like somebody going farther from home and then staying and then coming home, something like that. Ordered pairs are how we kind of notate where certain locations on the graph might be. Like if I want to talk about this point right here, I go to the x coordinate on the x-axis and then the y coordinate on the y-axis, and that would be ordered pair 2, 4. And if I want to go talk about where we start, that is 0 on the x-axis, 1 on the y. Those are called ordered pairs. They're locations on the coordinate plane. And then sometimes we also list lots of ordered pairs on a table like this, rather than putting them in parentheses individually. And we could list like a whole lot of points on this graph by saying, 2, 4, that's this one, x. Remember the x coordinate is first, the y coordinate is second. And then 0, 1 also on there. Another point on there appears to be 1, 2. Another point on there appears to be 3, 4. Another point on there appears to be 4, 3, and so on. So sometimes we just list lots of ordered pairs on the table rather than listing them like this, but same deal. So that's all past stuff. So let's talk about first what this word means. We're going to be talking about relations or relationships today. Remember, those are simply a relationship, how two things are related. So it's usually for us been time and like distance or elevation or something like that. So in this graph, this shows something starting 15 feet off the ground or off of whatever the starting point is, decreasing down until it's 0 feet off the ground. So here it's like on the ground or at the bottom, something like that for a little while, and then up it goes after that. And so that shows us how in this situation, elevation and time are related, a relation or a relationship. So if we start with the graph, there's usually 4, actually even 5 ways to talk about relation or relationships. And we're going to focus on 3 of them today. So if you start with a graph, the most common way to also represent that relation or relationship is with an ordered pair table. So take some points on that graph and make sure they're here. One of them that we almost always want to use is the starting one. So at 0 seconds, if I want to even make note here, my x-axis here is time. Sometimes I like to put that on my chart. And my y-axis here is feet. That makes it seem a little less abstract. So we usually start with like when x is 0 and work our way down. So when x is 0 at 0 seconds, looks like we're at about 15 feet. And then I obviously don't have room in my table to do every point on this graph. You definitely could, and it would be a good way to do it. Sometimes we look for points where there's changes. So there's like a change here. There's a change here. Looks like there's a change here. And a change here, maybe a change here. So sometimes we look at like some certain main points on the graph where they change. So if somebody had this and wanted to draw this, they could connect the points. I'll probably do that. So another important point on that graph, the first place I kind of see some change in direction, just ever so slightly, it gets a little less steep here, is at 4, 3. Then a very important point here, here's where we flatten out on the ground. So that's at about 5.5 on the x. And of course, 0 feet off the ground on the y. Another important point is how far the next time it changes, which is here. It looks like it's at about 8 on the X, 0 on the Y. So that's 2.5 seconds. Whatever's happening here is no feet off the ground. Then another one, if I'm right about this, it looks like it goes gradual and then a little steeper and then flattens out. I'll put that next one here. That looks like 13, maybe 10, I'm going to estimate. And then this one where it looks like the end to where it flattens out, that's about 14 seconds and about 14 feet. I'm estimating the feet. And it would probably be good to note that at 15, that's where the graph ends. If we do the first one, it's probably good to do the last one and say there's another one at 15. So I could have done every one of them. I could have done, 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds. That would have been a lot to do on this graph. It's nothing wrong with it. And if, in some cases when there would be a lot to do, I'll just do the main points like that. So this is the main other way we tend to represent relations. You'll usually see them this way and this way for now. I want to make sure you know that this and ordered pairs are the same. So we're also going to represent this one with just ordered pairs. They're all here. I just don't want you to worry if you see these and think that maybe something's up. So this one I also could have just put all of those ordered pairs just down separately. 0, 15, 4, 3, 5.5, 0, 8, 0, 13, 10, 14, 14, and 15, 15. Also just fine. It's just a little less organized, so you more often see them this way, but this is also a way to do it. The last way you're going to often be working with relations is from an equation. We're not going to deal with that right now. We're going to save that for later, but just know that is a common way to do it too. We're not ready for that yet. So let's start with a graph. Some more words for you today. Important words I want to add in: domain and range. So when we look at this relationship or relationship, domain, the domain of this relation is all of the possible x values. So on the x-axis, that's this one. It's everything x could be. So in this situation, x is any number between 0 and 15. We would just say the domain of this function is 0 to 15. Not even just the integers, because again, we wouldn't say, 1 second, 2, 3, 4, 5. We can look at what's happening in between at, say, 3.5 seconds or 4.2 seconds or something like that. So just all the x values that are possible in the situation. So here, whatever's happening here, it's everything between 0 and 15 seconds. That's called the domain. I'll say 0 to 15 seconds. The range of a relation or a relationship is all the possible y values. So that's here. The y-axis in this case is feet. The lowest number of feet in this relation is 0. The highest number of feet in this relation is 15. So it's also, the range here is 0 to 15 feet. That's a biggie. It's just like when you talk about the relation, what x values are possible, what y values are possible. And the least risky way to do this is from the graph. I'll talk about that on the next example. It's easy to find those from the graph. It's a bit harder from the tables. So what if our relation starts with ordered pairs rather than with a graph? So in this case, I've got this one and not the other ones. So it's easy to go from this to this because those are the ordered pairs. So if you just wanted to list your ordered pairs, they'd be at 0, 0. They'd be at 3, 74. They'd be at 7, 110. And 11, 74. And 15, 0. So that's pretty easy. Those are just those ordered pairs. If you don't have a graph, you just kind of got to make it. So I can take that table. I've got to make my graph. It doesn't tell me what I'm graphing here. What is x? What is y? I don't really know in this case. Maybe it's seconds and feet or minutes and home, or I don't know. It doesn't tell us in this case. So I'm going to make my graph here. It looks like the x's go from 0 to 15. So I'll do zeros obviously here. I'll maybe do 3s. 3, 6, 9, 12, 15. Looks like my y's go up pretty high to like 110. Two of them are 74s. So I'm going to kind of want one close to that. So maybe I'll do like 25 or something, because then I'll hit 75, which is really close to 74. 125 ought to do it. So I'll set that up. Again, that's my x-axis, that's my y, and I just have to put the ordered pairs in. So I've got one here. I've got one at 374, just a hair below 75. Got one at 7, which I don't have on my x-axis exactly, 110. So 7's about here, 110's about here. Then 1174. Then 15, 0. I've got this. Most likely from here, it doesn't include, remember we didn't put every point and everything in between. So most likely, unless it tells you not to, I would assume those are going to be connected. They may not be. You know, it is possible that it's just 5 separate points like that. But we're going to assume, unless it tells you otherwise at this point, they probably connect. So the things in between are in there as well. So like it didn't put on the table, say at this point at 995 or something, but it's there. Didn't put this point at 1425, but it's there. It just listed some. So we make the graph, and there you go. So then again, domain and range. Domain and range are easiest from a graph. So here's the graph that we just made officially. There, it looks pretty close to mine. I did a pretty good job. So it's easiest from the graph because if you look back here, it's hard to know all the possible x and y's because they don't show them. They just show some of the x's and some of the y's. So it's less risky to get it from the graph. So the domain of a relation or relationship is all of the possible x values. So remember, this is the x-axis. It turns out this graph was time and feet. So time, our time is, again, from 0 to 15 seconds. Whatever's going on here looks like something is like going up and then going down. That's the whole possible thing. It stops after 15 seconds. As far as we know, nothing else goes on from there. The range is all of the possible y values. So we saw this in the table. The lowest y value here is 0 feet. The highest one was here. I remember it being at 110 feet on the chart. So I assume that's the top. I went back the wrong way. Looks like the top here, 7, 110. So I'm going to say the range is 0 to 110 feet. And notice it's everything in between. It's not just, that's why I say it's less risky from the graph. If we look at this, you might say, oh, well, all the possible y values are just these and not the ones in between. But that's not the case. It's everything in between. When we see the graph, we can tell it's everything in between. Less risky from the graph. Okay. Yeah, I know that was just an I do. I'm about out of time, and I think that is plenty of an intro before class tomorrow. I know I usually like to have you write the we do too, but this is going to get super long if I do that. I'm already at 13 minutes, and I get cut off 15. The only choice would be to make a second video. It would take this up to half an hour, and I don't think that's necessary. I think this will give you a good start tomorrow. If you want to feel really good about it, watch it again. Make sure you feel good about the words domain, range, relation, relationship, and graphs and ordered pairs. Once you have all that just in mind, I think you'll be in good shape. We'll do your we do's tomorrow in class, and I'll see you then.